right, let's look at a problem in pressure. How would we do this? We've got a boat. Our problem says, got a boat, and the boat is 75 kilograms, right? Buoyant force on the boat, so we have a force upward from the water. The force buoyant is 1,000 newtons. So it says, what can we put in the boat? So how much mass can we load it with and get it not to sink? So the first thing we probably better do, because we're dealing with some forces, is draw ourselves a free body diagram. So if we draw the boat, our dot, there's our boat. We have a buoyant force up, and then we have two gravitational forces, right? We've got the gravitational force of the actual boat, because it has a mass. But then we also have the weight or gravitational force of the mass of whatever we put in it. Okay, so now we've got our free body diagram, so we can look at that and we can do a sum of the forces, right? Sum of the forces equals, and let's label which way on our diagram, we'll use a different color here, is positive. Let's say, go with the standard that up is positive. So then, the force of the boat, or sum of the forces is the force of the boat plus the force of gravity or the weight of the boat plus the force of gravity or the weight of the mass, whatever we put in it. And when we add all those together, that's the net force. Now remember, let's come back over to which way we said was positive. Over here we said positive was up. So that means gravitational force is going to be in the negative direction for both of these weights. So that would say that the buoyant force minus the gravitational force of the boat minus the gravitational force of whatever mass we put in is the net force. So which one are we going to find? Well, if we want to know up here the mass that we can put in, well, we've got to find the gravitational force or the weight that we can put in the boat, and then we can ask how much mass is that weight. So let's rearrange our equation for the gravitational force of the mass. So we're going to move the buoyant force over by subtract buoyant force from both sides. So that's going to say that the negative gravitational force of the boat minus the gravitational force of the mass equals our net force minus our buoyant force. Then we got to move our gravitational force. So we're going to add our gravitational force of the boat to both sides. So that says negative gravitational force or weight of the mass equals the net force minus the buoyant force plus the gravitational force of the boat. Now we got this minus sign in front of the gravitational force of the mass over here. So we're just going to multiply everything, right, by -1. Get rid of that. And turn the signs around for all of them. So that says that the gravitational force or weight of the mass is negative of the net force plus the buoyant force minus the gravitational force of the boat. Okay? Okay? So let's look at each one of these. So what is the net force? What is the buoyant force? And what is the gravitational force of the boat? Well, the net force, if we go back up here, we want it to go without sinking. That means it's just going to float on the water. So that means it's neither accelerating up or down. If no acceleration, that means the net force is 0. There's no change in motion. Buoyant force is given to us in the problem. Doesn't it say right here? Buoyant force on the boat is 1,000 newtons. So we know that one. So we can come back down here and we can say that's 1,000 newtons. What's the gravitational force of the boat or the weight of the boat? Well, we have the mass, right? The mass is right there. It tells us it's 75 kilograms. So if we look on our formula sheet, we know to calculate the weight, that's the mass times the gravitational acceleration. So the mass is 75 kilograms times our gravitational acceleration. Remember, you need to memorize that. That's 9.8 meters per second squared. That's the gravitational acceleration on Earth. So 75 times 9.8 meters per second squared works out to be about 735 and a kilogram. A kilogram meter per second squared is a Newton. So now we've got all our values. We've got our net force, our buoyant force, and our gravitational force, so we can put them in our equation over here, our sum of the forces. So the gravitational force of the mass, or the weight, is, we got that negative, but that's 0 newtons, so that's not going to make a difference for us, right? Plus the buoyant force, 1,000 newtons, minus our gravitational force of the boat, which is 735 newtons. So 1,000 minus 735, so our gravitational force of the mass is, if we plug that in our calculators, 265 newtons. Now remember, we're looking for the mass. That's our gravitational force, so we've got to get our mass again. So we've got to come back to our weight equation, or our gravitational force equation. That's m times g, right? We wanted the mass, so we're going to have to move that gravitational acceleration by dividing both sides by that. So that cancels. So that says our formula is going to be our mass. It's going to equal the gravitational force of the mass divided by gravitational acceleration. So we go back up, get our gravitational force of the mass. That was 265 newtons. That's the most that mass can weigh and not sink the boat, because we had that 0 net force, divided by 9.8 meters per second squared. So 265 divided by 9.8 is 27.04. And what units? Remember, inside that Newton is a kilogram meter per second squared. So the meters per second squared leaves us with kilograms. And so kilograms is a mass, so that makes me feel good that we're on the right track for that one. And so that all works out. So our mass, the most mass we can put in that boat and not sink it, is 27.04 kilograms.